some of the basic pages on here and just kind of review a few things that are somewhat of problem areas. I don't have time to do all of them, but then you can do a lot of these and come next week to recitation with your questions to go over that too. Okay, well, the first thing I'm going to do on this is I'm going to do number 4. This is always kind of a good type of test question because it tests several things at the same time. Okay, so one of the things is you've got a 4th degree polynomial, and I've given you 2 zeros. Okay, now the first thing is 5.3 on your exam had to do with complex zeros. We didn't have that on exam 2. Okay, so here's the first question I want to ask you. How many total zeros do you have if the degree is 4? 4. How many did I give you?
2.
Okay, do you know the other 2?
Yes.
Yeah, because you got that thing we called the complex conjugates theorem, right? Okay, so your zeros are going to be 2i, and then you know that negative 2i is 1, 2. Negative 3i I gave you, 3i. So partially what that problem's testing is do you know the complex conjugates theorem? Now what we're going to do is we're going to formulate a polynomial. So we just say x minus 2i. Remember, when you're formulating your factors, it's always x minus whatever the 0 is. Okay, that's real important when you do that. So I'm going to write this as x minus 2i, x minus negative 2i. Same thing here, x minus 3i, x minus negative 3i. You can skip that step because the minus is going to go to a plus anyway, right? So what I'm going to have is I'm going to have x minus 2i times x plus 2i, and then x minus 3i times x plus 3i. Okay, now what I have you do on this, I want you to multiply this out. So the problem that follows on the number 5 is essentially the same kind of problem. So this is kind of a good exam type of situation because the arithmetic is not too heavy. Okay, I mean, it's just kind of a standard problem. So what we're going to do is we're going to FOIL this and we're going to FOIL this. Okay, now what happens on this, you want to know shortcuts. Okay, when you do the inner and outer, what happens when you do inner and outer on this thing? They cancel. Good. Same thing here. Inner and outer cancel. So all you got to do is the first and last terms. Okay, to save time. I mean, you can go through all 4 steps of FOIL if you want to, but if you see the shortcut, just do the shortcut. So this is going to be x squared minus 4i to the second. Okay, the next one's going to be x squared minus 9i to the second. Okay, so here's a big deal. What is I squared? You want to make sure you know that. Negative 1. Okay, I don't give that to you. You got to know that. So what you're going to do is this would be x squared, and you can do this in your head. All this is 4 times negative 1, so that's going to become positive 4, right? Same thing here. That's negative 9 times negative 1, so it's positive 9. You don't have to write that step out. You can just do that in your head if you want to. So that's x squared plus 4 times x squared plus 9. Then I want you to FOIL it out. Okay, so now you got to go through and FOIL the whole thing out, and that's the answer I'm looking for. So you would have first term, x squared times x squared is x to the 4th. Outside term would be plus 9x to the 2nd. Inside term would be plus 4x to the 2nd. And then plus 36. Got like terms, so the answer that you would have for your polynomial would be x to the 4th plus 13x squared plus 36. So if you look back at in your notes, we did that same kind of problem in class, and you probably did that on your homework a little bit. That's the type of thing that I want students to know with complex conjugates theorem, is to be able to formulate a polynomial and multiply it out. Some of those problems can get pretty heavy. That one's not too bad. That's about the level that I'm looking at there. Okay? Is everybody okay with what I just did there? Okay? All right. And then I'm not going to review 1, 2, and 3. Those are kind of the kinds of problems sometimes I just put on the multiple choice part. You want to know the complex conjugate theorem. That's kind of applying the same thing. Okay, next thing I'd like to review is the 0. So what I do on a test is I give you a polynomial and I give you a 0. Okay, I give you the first 0. Let's do number 6. Number 7 is similar. Number 6 has an extra step, so I'm going to go ahead and do this one. Okay, so what I do is I'm going to give you a 0. So you're going to do synthetic division. Okay, you're going to divide by negative 2i. Okay, now remember, a lot of what we're doing here is complex numbers. Okay, when you put the numbers under the division symbol, do you have missing terms?
Yes.
Yeah, so make sure you follow that. You don't have a third power, so put a 0. You have negative 5, you're missing an x, put a 0 and a negative 36. So make sure that you're always paying attention to those things then, okay? All right, now we're going to do the synthetic division, but we got to deal with the I. All right, so what happens on this? You bring the 1 down, then you multiply. Negative 2i times 1 is negative 2i. Then you add the column, so that's negative 2i. Okay, next thing you got to do, you can do this in your head or at the side of your paper like on Scratch. What I'm doing here is you're doing negative 2i times negative 2i. So that's 4i squared, but what is 4i squared? Negative 4, right? Okay, you can do that in your head. That's negative 4, right? So that's going to be a negative 4 there. Okay, and then you're going to just go back through the same thing. Add the column, that's negative 9. Now multiply negative 2i times negative 9. So that's going to give you positive 18i. Okay, add the column, that's 18i. Okay, and then finally what you do is you do negative 2i times 18i. That's negative 36i squared, but what does that become? 36, okay? And that's what you're going to expect to happen anyway, is have a remainder of 0, okay? So you want to make sure that you know how to handle that okay with an imaginary number, okay? Now, we got to go divide again, okay? How many zeros do we have? The highest degree of this polynomial is 4. I only gave you 1. How many more do we got to get? We got to get 3, so there's our first 0. We got that. So you have to know the complex conjugates theorem. What you're going to do is you're going to take this result, and then you're going to divide it by another 0 that you know. Is there another 0 you know?
Yes.
What is it?
2i.
Good, 2i, complex conjugates. If negative 2i is a root, then so is 2i. Okay, so you got to do it again. Okay, like that. Remember, you got 4 zeros on this problem. Okay, so we repeat the process again here. So bring down the 1, multiply, that's 2i. Add the column, that's 0. This one's a little easier. Multiply, that's 0. Add the column, that's negative 9. Multiply, that's negative 18i, so you have a remainder of 0. So right now we have our second 0 is 2i. We already knew that. Okay, now what do you do? Let's solve the equation that's left over. So remember, this is a remainder. That's a constant term. That's x. That's x to the second. So what you really have is you have x to the second, 1x to the second, minus 9. That's what's left over. Now what you need to do is take that and set that equal to 0. And when you solve that equation, you've got your other 2 zeros. Okay, so either factor it, or you can do the square root property. So I'm just going to go x squared equals 9, square root both sides. So what are the other 2 answers? Plus minus 3, good. Okay, so your answers to this problem are 2i, 3, and negative 3. So you want to know how to do that. That's the way I like to do that on a test, is give you a 0, have you find the other ones, okay, like that. Number 7 that follows is fairly similar, okay? Those are pretty similar problems, okay? All right, you guys okay with what I just did there? Remember that okay? Okay. All right, let's see. Let me skip down a little bit here. Let's kind of talk a little bit just about rational functions here just for a few minutes here. Some of the stuff from 5.4. 5.3, mostly you're looking at complex conjugates theorem and being able to work with that and finding zeros given a 0. Okay, let's look at domain of a rational function. Let's go over that just a few minutes here. Okay, whoops. So, that thing just disappeared. I have no idea how. Okay, let's go over domain. All right, so if you have a rational function, you have a polynomial on top, polynomial on bottom. What do you look for on the domain? You look for problems, right? Which on a fraction, what's the problem? Zero denominator, exactly, okay? So one of the things you always want to do, and this is pretty important, is it's a good idea to simplify first. This one doesn't simplify, but you can factor an x out of the bottom. So factoring is kind of a big deal in this problem, so you can pull an x out, so you'd have that. Now notice, nothing cancels out. If something cancels out, then that doesn't have anything to do, it doesn't matter on your domain. Your domain is, you always look at that. You look at the denominator, and you figure out what causes it to be 0. So after you do that, what is the solution to this equation right here? 0 and 49, right, okay? So what you would say is, if you said this in set builder notation, you would say set of x, and you would just say x is not equal to 0, x is not equal to 49. Okay, when you state it that way, you're telling me it's okay for x to be any number except those two right there. Okay, that's it. Okay, next one you're going to do exactly the same thing on. You look at that denominator, and you set it equal to 0, and you try to find problem areas if there are any. If you solved this equation, you could do the square root property. You could move the 64 to this side, which would give this. Then if you square root both sides, what's the deal? It's an imaginary number, right? Okay, so what is the domain? We don't care about imaginary numbers. So that means we didn't find anything that caused a 0 denominator, so what's the domain? All real numbers, exactly. Everything, okay? Okay, that doesn't count, okay? We're only looking at real numbers. See, that thing right there is an imaginary number, so that means the domain is just all real numbers. Okay, and, you know, if I wanted you to write that in interval notation, you'd just say negative infinity to infinity, okay, like that, okay? So again, you're looking at potential things that cause the 0 denominator. Think of it this way. If you don't understand that, think of it this way. Can you think of a number you square, add 64 to, that would ever give you 0? No, okay? If you square a number, you get a positive, or you get 0, okay? You're never going to get 0 out of that. You can think of that through that in your head if you want to, like that, okay? All right, next one, let's see. Let's go ahead. I'm going to skip the next one because it's about the same thing. And then I'm going to go, let's talk about an oblique asymptote. Let's go through that. And go and put that kind of together here, okay? I'll tell you what, before I do 15, let's just quickly kind of review the horizontal asymptote. Okay, I gave you a set of rules that allowed you to kind of quickly, on a rational function, tell what the horizontal asymptote was. Remember, horizontal asymptote is y equals something. Do you guys know what the horizontal asymptote on this is by looking at it? What? 9, good, okay. What's the degree of the top? 1. The highest exponent's the degree, so that's 1. What's the degree of the bottom? Anytime the degrees are equal, there's your answer right there. That's called the leading coefficient. It's 9 over 1, okay? That's a rule. You want to know that rule. You go back and look at your notes on 5.4. I gave you the series of rules that you need to review. So this one would just be y equals 9 over 1, or just y equals 9, okay? The next one, I'm going to multiply out the numerator, so that's x squared minus x over x cubed plus 25x, okay? What's the degree of the top on this? 2. Degree of bottom? The degree of top is less than the degree of bottom. Do you know what the answer is? 0. Okay, that's a rule, okay? That's how you do that. It's not hard, you just got to know the rule, okay? Now, if you look at the next one, degree of top is 2, degree of bottom is 1. This is the other possibility. If that's bigger than that, then there is no horizontal asymptote, okay? You can get an oblique asymptote, okay? So that would just be none. Those are the rules, and that stuff, man, you just want to review and make sure you know those rules, and there's really nothing to that, okay? So if you go to number 15 now, the reason this has an oblique asymptote is because the degree of the top is 1 bigger than the bottom. So the way you're going to do this is you got to do a long division problem. And you could do this one with synthetic division because it's x plus something, or you can do it long division. I'm going to do long division on this one. just kind of choose to review it that way. And what you're going to do with this then is, remember when we do long division, you start by dividing these two terms right here. So you can do this in your head. I'm going to kind of write down what I'm doing. So x squared divided by x is x. So you can record that then. Okay, then the next thing you do is you take the x and multiply it by x plus 5, which you do in your head. X times x is positive x squared. X times 5 is positive 5x. Okay, then what you want to do is you want to subtract, which you can do in your head. This is where students mess up all the time. So this minus this is nothing, right? How about this? What would that be? Negative 13, because that's negative 8 minus 5. Okay, so that's going to be negative 13 like that. And then you bring down the next number. And then you got to go through this loop one more time. So now we're going to start all over again with these two numbers. So we're going to have negative 13x over x, and that's negative 13. So it goes like that. Okay, then we multiply, so we do negative 13 times x plus 5. That's going to give negative 13x, and then negative 13 times 5 is negative 65. Okay, so what happens is, this is going to be minus a minus, right? That's going to cancel, it always will. What is this thing going to do? Try to do that in your head. Remember, you're doing minus a negative, right? So it's 69, right? This is 4 subtract a negative, so it's 4 plus 65. You're subtracting a negative. That's where students mess up on that all the time. Okay, well what happens is, there's your oblique asymptote right there. So you end up with y equals x minus 13. The remainder doesn't have any bearing on that. It's the result of the division. So that's your oblique asymptote. Okay, all right? So, and your oblique asymptote is going to be a line. Yes? You okay? Yeah. Yeah. What happens on this problem, I mean, you end up getting x minus 3, and then you say plus 69 over x plus 5. This part right here just goes to 0 when x gets bigger and bigger and bigger. So that's why, whoops, x minus 13 is the answer. Okay? Okay, let's look at that. Let's do a graph of a rational function, because that's a big thing that you want to be prepared to do, is to be able to do a graph of a rational function. So let's do 25, okay? And then you want to be able to do this. This is kind of a big problem that you will see on your exam. I give you a rational function, I have you do these things. Find the vertical asymptotes, find the intercepts, and then sketch a graph of that, okay? And you're doing this without a calculator. So let's go through this whole problem, and I'll show you the kind of the way that I test over this kind of thing. So typically, what I would do first is I would probably say, okay, give me the vertical asymptote, and then I would probably say, okay, give me the equation of the horizontal asymptote. Then I would get into the intercepts, and then we would kind of get into the graph like that. Okay, so what you want to do to find a vertical asymptote, the numerator's already factored on this example. How do you factor the denominator? It does factor. How does that go? X plus 6, x minus 6, right? Okay, so one of the things on this that you want to do is, nothing's canceling out. So the vertical asymptote, you're going to have two, whoops, I missed a minus on that, didn't I? So it's x plus 6, x minus 6, okay, like that. Okay, so what are the two vertical asymptotes? You look at the bottom, right? Okay, so if you look at the bottom, you're going to have x equals negative 6, and you're going to have x equals 6. So those are the equations of your vertical asymptotes, okay? Now let me see if you guys remember this or not. Now, it's been a while since we've done that. What if something canceled out? What if the x minus 6 canceled out? It's not an asymptote. Do you remember what it is? It's a hole, right? So be careful about that, okay? If one of them cancels, you have a little bubble in there, okay? All right, now let's look at the horizontal asymptote. You can do this in your head because it's a series of rules, but if you multiplied out the numerator, you would have x squared plus 3x minus 1x minus 3 over x squared minus 36. You don't have to do that either, because you can do this in your head. Okay, the degree of the top's 2, degree of bottom's 2, they're equal, therefore what's the horizontal asymptote? This over this, 1 over 1, right? Okay? Anytime the degree of the top is the same as degree of bottom, there's your answer right there. So it's 1 over 1. Okay? So what you would have here is your horizontal is going to be y equals 1. Okay? You go back to when we were kind of reviewing horizontal asymptotes, that's how you know. Okay? All right? So now the next thing we would probably do is find x-intercepts. Okay? When you do an x-intercept, what you do is you set y equals 0. So you would just solve the equation x minus 1 times x plus 3 over x squared minus 36 equals 0. That's an equation that has a fraction in it. So what do you do if the equation has a fraction in it? Get rid of it. So you'd want to multiply by this on both sides. You can skip this step, but a lot of times when I'm teaching this, I don't like to teach students just set the numerator equal to 0. I prefer that you just do this and understand why you do that. So we're going to do that to both sides. That's going to end up giving you x minus 1 times x plus 3 is equal to 0. Okay? So that means the x-intercepts are x equals 1 and x equals negative 3. Okay, so you'd have a point 1, 0, and you would have a point negative 3, 0 like that. Okay, so you always, when you're working with a rational function, got to do the same thing. Okay, like that. Right? And then the next thing we would probably do is a y-intercept. How do you find y-intercepts? It's that x equals 0, right? Okay, so you're just doing f of 0. So if you do that and go to your original function, you would have 0 minus 1, 0 plus 3 over 0 squared minus 36. Okay, so if you work out the numerator, you have 3 times negative 1 is negative 3. Denominator is negative 36. And then if you reduce that fraction by 3, you would get 1/12. So you would have a y-intercept of 0, 1/12 like that. Okay, so that's standard stuff on a rational equation doing a graph, and this is something you want to prepare yourself for, is be able to find the asymptotes and the intercepts. Now the rest of this, you have to put this together without your graphing calculator, so I want to review how I taught you how to do that then. Okay, so let's go ahead and draw a little graph system here, a little coordinate system. And what you want to do is now begin to put this stuff together. Okay, so let's start with our vertical asymptotes. Okay, at 6 and at negative 6, you have vertical asymptotes. So you would want to go through and just put your asymptotes on there like that. Okay, and then you have you have a horizontal asymptote at y equals 1. So you'd want to put on that horizontal asymptote. You want to use a dashed line kind of like that. Okay, and let's see, we also got intercepts, so I'm going to go ahead and put the intercepts. So I have negative 3, 0 is an x-intercept. 1, 0 is an x-intercept. And let's see, what else do I have? I have a y-intercept 0, 1, 12. So you have a y-intercept kind of like that. Okay? Now, the thing that sometimes students don't do so hot on this problem is this. If you're doing this without a calculator, you got to make a sign chart, all right, to kind of analyze how everything goes. Now, what you have to do is you use these things, and this is important. You might want to write this down. You use the vertical asymptotes and the x-intercepts. So this sign chart is going to have a lot of things we have to look at, okay? So what we would end up doing with this is we have negative 6, just do it in order. We have negative 6. We have an x-intercept at negative 3. Okay, we have another x-intercept at 1. And then we have another x-intercept we have a vertical asymptote at 6. So that's what you have to do, is you have to pay attention to your vertical asymptotes and your x-intercepts. And then you've got to do test points on this. Okay? Now, I'm going to run through one of these test points, and then I'm going to just sort of tell you what the results are, because I don't want to bog down and spend a lot of time on that. But if you go to what we're working on. We're working on x minus 1, x plus 3, and then if you factor that, it's x plus 6, x minus 6. So what you're going to do is you're going to plug in test points and try to figure out if it's negative or positive. Okay, I'm going to do this region here and this region here. Okay, just those two, because I know what the rest of them are. I can tell by looking. You can too. Okay, so what I'm going to do here is let's take a test point like -7, anything less than -6. You want to plug it in here. So if you plug that in, you're going to have -7 minus 1, -7 plus 3, over -7 plus 6, -7 minus 6, like that. Now really what I want to see on your sign chart is I want to see just kind of the result of this. So if you look at this, just look at these four parts right here. You would have a negative times a negative, that's negative, over a negative times a negative. Okay, that's a positive over a positive, so it's a positive. So what that means is your graph is above the x-axis. Okay, that's how you have to reason that out. So what you know is when you're out here, your graph is up here. All right, here's what you got to know. If you're up here, how does a graph behave around a vertical asymptote? There's only two ways it can go. What are they? It can go up, that way, touching, almost touching, or it can go down. Which one makes sense? Going up, because if it goes down, then you're going to get below the x-axis. How does a graph behave at a horizontal asymptote? When you're going this way, what happens to the graph? Levels off. Okay, remember, it gets close to asymptotes. You're always getting close to asymptotes. So what's going to happen then is this graph is going to behave like this, and it's going to behave like this. You'll sketch it. I need to see that you understand how that thing approaches the asymptotes. And the whole reason is because that test point proved that we were always above the x-axis. That's the only possible way that can go. All right? So I'm going to do one other thing here. Okay? And I'm going to do a test point out here. And let's say that we have 7. Okay? So again, if we go here, we would have 7 minus 1 over 7 plus 3 over 7 plus 6 times 7 minus 6. Okay, so you can do the sign stuff in your head. This is just a positive times a positive over a positive times a positive. So again, it's positive. So the same thing happened. Whoops, I'm putting that in the wrong place on my sign chart. Okay, so you'd have a positive there, and then you would be above like that. Okay, so what you would end up having is, if you did the graph here, it's going to look the same. It's going to have to go that way and that way. So it's going to kind of do that shape like that. Okay? All right, and you'd end up having just sketching the graph like that. Now, what would happen if you did the next part of the sign chart? This would be negative. I'm not going to take the time to show you what I do because it's still the same thing. Then from here, it would be positive, and then here it would be negative. So what would happen is this graph would do this. Between -6 and -3, you're below the x-axis. That means you'd have to do that. You'd have to go down towards the asymptote. Between -3 and 1, you're above, and it would have to connect through those intercepts, so it would go like that. And then from 1 to 6, you would be below. That just means it would have to go down forever, approaching the asymptote like that. Okay? Now that's something that's really a big deal on the test. This is the main problem that puts it all together. So you want to know how to do a graph like that without your calculator. Okay, does everybody understand that okay? And that sign chart is something you want to be sure that you're totally on top of now. Okay? Okay, let's move through a little bit more of this. I'm going to do a couple things. I want to see what's on the next page. And see, I want to look at here, probably composition of functions. I probably want to do one of those. I don't know if it matters which one. Let's go ahead and just review like a few composition of functions problems here. All right, let's do this one that's got the table in it. And then let's just do something like maybe that 34 just for an idea, kind of get the idea and an overview. Okay, so what you're doing on 29 is, to me, when you're doing a composition of functions, the key is to write the first step. Write this as G bracket f of 1. Then you can start reasoning through what you want to do. Okay, so f of 1, you got to look at my chart. Okay, and on my chart, what you're doing is you're going to 1. What's f of 1? -3, right? Okay, so the result of f of 1 is -3. So you would write this like this then. So you would say that would be g of -3, right? Okay, now look at the second one. If x is -3, what's g? -6, right? Does everybody see what I did there okay? All right. That's a composition of functions with a table. So that thing gives you that point -6 like that. All right. That's a basic thing I want you to know how to do, is to look at that composition in more of a table format. Okay. Let's look at, let's go down and do like this 30 and 34, just kind of to give you a little quick review here. So you're doing G composed of f of 2. Okay, so that's going to be G bracket f of 2. That, to me, that's the key, is to write that on your paper like that. So you're going to start with f of 2. The way to find f of 2 is to work with this function right here, f of x equals 4x plus 6. Well, what you're going to do is you're going to replace x with a 2. So you have 4 times 2 plus 6. That's 8 plus 6, so that's 14. Okay, so that 14 plugs in here. So you would have g of 14 like that. Now what do you do with that g of 14 to close off the problem? You just plug it into g. Okay, so g is, I think I wrote over that so I can't see what it is. That would be 4 times 14 squared plus 5. Now then just work it out. I'm not going to work it out, but the main idea on that is to get that, know how to put those things together in the right order. So that's composition of functions. You want to know how to do a basic composition of functions, and you also want to do something like 34, where you're given 2 functions and you make a function out of that. So this 34, you're working out f composed of g of x. So you write down the first function. So when you do this, just write down f of x. But instead of an x, put like a parenthesis. So it's something plus 8. Now, what goes in the parenthesis? What? The other function. Good, thank you. 8x minus 12. So see, what you're doing is you're plugging the right function g into the left function, so you would have this. So that's how that goes. Now, sometimes these are not much to simplify. This one you would just have 8x, and then -12 plus 8 is minus 4. Now, that one can be simplified. Any idea what you can do with the 8x minus 4? What does it look like? What's a common thing that you do with algebraic expressions? It begins with f. Factor. Okay, you can factor a 4 out. Okay, so what we're going to do is we're going to factor a 4 out of there. Then we're going to have 2x minus 1. And then what can you do with that 4? Remember, we're doing a square root. So square root of 4 is 2. So you could do that. So you would have 2 times the square root of 2x minus 1. That would be your composition of functions right there. And I definitely always want you to simplify those things as far down as you can then. Okay, that's pretty important. Okay, so that would be kind of the idea with, those are the main things for composition of functions that you want to know how to do. Let's see, I'll be posting solutions on this tomorrow. And then you guys can kind of look at those over the weekend, and anything that you need to go over in recitation you need to do. So I'd recommend that you try to